Assalamu alaikum. Welcome to lecture number 21 of Software Design and Architecture. I am your course instructor Fahad Anwar. So, students, before I start today's lecture discussion, I would like to give you a little bit recap about our last lecture. So, students, if you remember what we discussed in our last lecture, we discussed a distributed software architecture where we see a client server architecture pattern and service oriented architecture pattern. For both client server architecture and service oriented architecture, we discuss their structure with the help of some real world example. We also discuss what are the possible applicable domain areas where these distributed software architecture can be utilized. Discuss we also discuss their advantages, disadvantages, or limitations as well. So this is a little bit recap about our lecture number 20. So let's formally start the discussion of lecture number 21. So here is a brief objective of our today's lecture discussion. In this lecture we will discuss a data flow architecture in which we see a batch sequential architectural pattern and pipe and filter architectural pattern. We also discussed the structure of both data flow architecture. We will also consider some example and also discussed what are the possible applicable domain areas where these data flow architecture can be utilized, and we also discuss benefits and limitations of both of these data flow architecture patterns. So students, here are the categories of architecture styles which are we constantly being discussed from our previous lectures. In hierarchical layer based software architecture and client server and server oriented service oriented architecture, which are basically distributed software architecture, have been discussed in our previous two lectures. And now in this lecture we will discuss data flow architecture, in which we further see pipe and filter and batch sequential architecture pattern. So let's start with data flow architecture. So students, what is data flow architecture? Basically, data flow architecture actually provides the view of entire software system as a series of transformations on successive sets of data. So where data and operations on it are independent of each other. These are not dependent on each other. Data and their operations are independent of each other. So the software itself is decomposed. Software system is further decomposed into processing elements where our data directs and controls the order of data computation, processing as well. So you can also say that the software system is decomposed into processing elements where data directs and controls the order of data computation processing. So each component in this architecture transforms its input data into corresponding output data. So the connection between subsystem and components, you can say that it may be implemented as input output streams, input output files, buffers, pipes, streams, or other type of connections. So data can flow in a graph topology with cycles, or in a linear structure without cycles, or even in a tree type structure as well. There are students, there are different ways to connect the output of a module to the input of other modules, so which ultimately result in a range of data flow patterns. So basically in this data flow architecture, there are two categories of execution sequences between modules. First one is batch sequential, and the other one is pipe and filter, which is a non-sequential pipeline module. So students, there are two basically categories of these data flow architecture: batch sequential and pipe and filter. These two are types of data flow architecture will now cover in more detail, so that you can get better idea about these two data flow architecture patterns. So First one is batch sequential. So basically, what is the batch sequential? The batch sequential architecture pattern represents a traditional data processing model that was widely used from 1950 to 1970. So RPG and COBOL are two programming languages working on this model. So in this batch sequential architecture, each data transformation subsystems or module cannot start its process until its previous subsystem completes its computation. So data flow carries a batch of data as a whole from one system to another. So from this diagram you can get better idea about the batch sequential, how it actually works. So first of all, subsystems validate the transaction requests like insertion, deletion, and updates. These are the different transaction requests in the database. So next the second subsystem will sort all these transaction records in ascending order, or you can say that in a descending order on the primary key. So students, these are the different transaction requests: insertion, deletion, and updation, and sorting as well. So these are the different terminology, or a primary key. These are the different terminologies you have already been discussed in your database system subjects, which you already have been studied in previous semester as well. So I don't need to discuss in further details about these insertion, deletion, or a primary key concepts in this design and architecture course. So the further is the transaction module, which updates the master file with the sorted transaction request, and then it ultimately report module generates a new list. So this data flow provides the data transformation. So in other words, you can say that the architecture is in a linear data flow order. So this architecture, what it actually provides. So first of all, we validate our transaction request like insertion, deletion, and updation. And after getting these transaction, we also provide, so we sort all these transactions records in ascending or descending code order on the primary key of already available data records, and then we provide the updation to the master files with sorted transaction requests, and then the report module generates a new list. So it's, you can see that it's all communication between subsystem modules are conducted through transient immediate files, which can be removed by successive subsystem as well. So business data processing, such as for example banking and utility billing, are typical applications of this architecture. So this architecture is a linear data flow order. So, what are the applicable domain areas, or what are the applications where this batch sequential system architecture is normally utilized? Where we have data in a batch, where we have data in a batch file, or where intermediate file is a sequential access file. So, what is this intermediate access file? So this intermediate access file is basically where we have all communications between different submodules are conducted through transit through this immediate file, which can be removed by successive subsystem. So we use this kind of sequential architecture where each subsystem reads related input file and write output file. So these are the different situations where we can utilize this sequential architecture. So there are some benefits of this sequential architecture as well, like where we have simple divisions of subsystem, like where each system can be a standalone program which can be work on an input and producing some output data. So these are the benefits of this sequential batch sequential file system. So there are some limitations as well, like it requires some external control, it does not works well for interactive interfaces as well, or concurrency is not supported in this sequential file system. So once you do not get the concurrency, so the throughput remains low, and high latency is also a limitation of this batch sequential file system as well. So where you have some benefits, you will also face some kind of some limitations of this architecture as well. So the next one is pipe and filter. So now what is a pipe and filter? That it is a second data flow architectural pattern. So basically the in pipe and filter, the processing of the data in a system is organized so that each processing component is discrete and carries out one type of data transformation. So the data flows from one component to another for processing. So this kind of architecture commonly used in data processing applications for both batch and transaction based. So we normally used this kind of architecture where inputs are processed in separate stages to generate related outputs. We will discuss some real world example as well in the later part about this pipe and filter architecture, so that you can get better idea about the structure of pipe and filter. So this architecture basically decompose the whole system into components of data source, filter, pipes, and data sink. These are different components of pipe and filter architectural pattern. And then connection between components are data streams, and the particular property attribute of the pipe and architecture is concurrent and incremental execution. So this pipe and filter is basically provide us provide can be implemented as either a sequential or a concurrent system as well. So let's discuss its style as well. So it this kind of pipe and filter architecture is normally suitable for application that require that have a define a series of independent computations, or where we have a specific number of predefined stages to generate related outputs. In this kind of scenarios, it is more normally useful to utilize this pipe and filter architecture. In this pipe and filter, each component has a set of inputs and a set of outputs, and this and different components read a stream of data on its input and produce stream of data as its output. So in for this pipe and filter style, we will discuss some real world based example to get better idea. So let's discuss about the structure of pipe and filter structure. So here is the structure of pipe and filter. So students, here you need to put more focus on this slide. So here if you see what are the filters and what are the pipes. Filter are represented by the rectangles and pipes are denoted on these arrows. So basically students, pipe and filter architecture is one type of data flow architecture where the flow is driven by data. So here you can see that each filter is an independent data stream transformer. It reads data from input data stream, which transform and process it, and then writes the transform data stream over a pipe for the next filter to process. So similarly, a pipe, if you can see that a pipe moves the data stream from one filter to another filter. So a pipe can carry a binary or a character streams as well. Object type must be serialized to be able to go over a stream as well. So a pipe is replaced. You can see that a pipe is placed between two filters. These filters can run in separate threads. So thread is basically a mini process. So these filters can run in a separate threads of the same process as Java input output streams as well. So here pipes are represented by these arrows and filters are represented by the rectangles. So a pipe is placed between two filters, you can see in this example. So basically in this example, I show you how to represent a filter and how to represent a pipe. So basically pipe shows the flow of data between two filters. So or you can say that a pipe is placed between two filters. These filters can run in separate threads of the same process. So let's discuss some more real world example of this pipe and filter. It's a basic structural representation of pipe and filter structural pattern. So there are three ways to make the data flow: push only, which we call a write only as well; repull only, which we also call a read only; and a push and pull, or a pull and push, which we call a read over write as well. So in push and pull, a data source may be push data in downstream, so a filter may push data in a downstream. So what is a filter? We discussed in the structure of previous slide. If you look over here, a filter is basically pipe is basically placed between two filters, and filter is an independent data stream transformer. It reads data from its input data stream and transform and process it, and then writes it transform data stream over a pipe for the next filter to process. So The next one is pull only, which we also call the read only. So a filter may pull data from an upstream as well. So push only may push data in a downstream, and pull only may pull data from an upstream. So it's pretty straightforward. Push only utilized to push data in a downstream, and pull only, which we also call a read only, may be utilized to pull data from a upstream. So pull and push, which we also call a read and write. So a filter may pull data from an upstream and push transform data in a downstream in both directions as well. So these are different, push only, pull and push. These are the different three interchangeably different terms which are basically need to be understand in pipe and filter structure. So let's discuss sales example of this pipe and filter structure to get better idea about pipe and filter architecture. So students, here my question to you is, in what kind of scenarios we can use this pipe and filter architecture? So students, you must remember, we commonly used this pipe and filter data flow based architecture in data processing applications for both batch and transaction based, where inputs are usually processed in separate stages and generate related outputs as well. So let's discuss a pipe and filter system used for processing invoice in this example, which we also call a sales system. So if we look into this architecture of sales system, used in a batch, processing application as shown in this figure. So an organization has issued invoices to customers. Once a week, payments have been made or reconciled with the invoices. For those invoices that have been paid, a receipt is issued. For those invoices that have not been paid within allowed payment time, a reminder is issued. So in this slide, if you look over there, read issued invoices, identified payments, issue receipts, all of these rectangles actually, rounded rectangles actually represents the filters, and the arrows and these filters are actually connected through pipes. So we can also say that interactive systems are difficult to write using the pipe and filter model because of the need for a stream of data to be processed. So we can also say that in this sales system, an organization is actually issued the invoices to its customer. So like payments have been made are reconciled with invoices. Like if you see in this example, for those invoices that have been paid, a receipt is issued, and for those invoices that have not been paid within the allowed payment time, a reminder is issued. So in this pipe and filter architecture, the processing of data in a stream is organized so that each processing component is discrete and carries out one type of data transformation. So student, this is the practical sales system base, or you can say that it's a processing invoice example for a pipe and filter architecture. सो व्हाट आर द एप्लीकेबल डोमेन्स ऑफ पाइप एंड फिल्टर? कौन कौन से एरियाज़ हैं जहाँ पर हम पाइप एंड फिल्टर आर्किटेक्चर को यूटिलाइज कर सकते हैं? सो दीज आर द डिफरेंट डोमेन्स वेयर वी कैन यूज दिस, with this pipe and filter architecture is actually applicable, like the system which can be broken into a series of processing steps over data streams, and each step filter consume and move data incrementally as well. And we can also use this architectural pattern where data streams is simple, stable and acceptable. So this pipeline can increase performance as well. So producer consumer related problems are also being addressed in this kind of data flow architecture as well. So there are some benefits of this architecture as well. So if we look into these benefits, so the first one is concurrency. So what is concurrency? So basically, in this pipe and filter, concurrency is provided. So it actually provides high overall throughput for excessive data processing, which helps to achieve the concurrency. Reusability is also being provided in this pipe and filter architecture. like encapsulation of filters make it easy to plug and play and to substitute as well. Modifiability is also being provided in this pipe and filter architecture, like it features low coupling between filters, less impact from adding new filters and modifying the implementation of any existing filters, etc. This pipe and filter architecture also provides the simplicity as well. So what is the simplicity? Like it offers clear division between any two filters connected by a pipe, as well as we discussed in a generic structure of pipe and filter, where we see filter is represented by a rectangle and a pipe is actually connecting between two filters. So it also provides flexibility as well. So flexibility means it supports both sequential and parallel execution as well. So where we have some kind of limitations, we also have disadvantages as well. So the main disadvantage of this approach is that it is not good for interactive systems because of their transformational characteristics. इंटरेक्टिव सिस्टम्स के लिए जो डाटा पाइप एंड फिल्टर आर्किटेक्चर है वो गुड चॉइस नहीं है। इंटरेक्टिव सिस्टम्स के लिए हम मोस्टली जो आर्किटेक्चर पैटर्न यूटिलाइज करते हैं, हम मॉडल एमवीसी पैटर्न को यूटिलाइज करते हैं। सो मॉडल व्यू कंट्रोलर पैटर्न को यूटिलाइज करते हैं। मॉडल व्यू कंट्रोलर पैटर्न क्या है, इनको हम कमिंग स्लाइड्स के अंदर डिस्कस करेंगे कि एमवीसी पैटर्न क्या है। सो टिल हेयर हमने क्या देखा, हमने देखा कि डाटा फ्लो आर्किटेक्चर जो हमारे पास है उसके अंदर बैच सिक्वेंशियल बेस्ड आर्किटेक्चर कैसे वर्क करता है एंड दिस पाइप एंड फिल्टर आर्किटेक्चर पैटर्न कैसे वर्क करता है। सो our today's lecture can be summarized that data flow architecture decompose the system into fixed sequence of transformation and computation. So we can also say that there is no direct interaction between any two consecutive subsystem except for the exchange of data through data links as well. So in this data flow centered architecture, no data sharing occurs among subsystems in data flow architecture. ये जो हमारे पास डाटा फ्लो आर्किटेक्चर है ये इंटरेक्टिव बिजनेस प्रोसेसिंग के लिए सूटेबल नहीं है। सो हमने दो डिफरेंट टाइप्स के डाटा फ्लो आर्किटेक्चर डिस्कस किए अपने इस लेक्चर के अंदर, जिसके अंदर हमने बैच सिक्वेंशियल एंड पाइप एंड फिल्टर को डिस्कस किया कि बैच सिक्वेंशियल एंड पाइप एंड फिल्टर जो है कैसे वर्क करते हैं डाटा फ्लो आर्किटेक्चर पैटर्न में। सो देन जो पाइप एंड फिल्टर है हमने कहा कि ये इंक्रीमेंटल डाटा ट्रांसफॉर्मेशन प्रोसेसिंग मॉडल है जो कॉन्करेंटली रन किया जाता है। सो देन जो हमारे पास डाटा फ्लो एंड कंट्रोल फ्लो है पाइप एंड फिल्टर में वो इम्प्लिसिट है, लाइक रीडिंग एंड राइटिंग इनपुट आउटपुट फाइल्स ड्राइव द डाटा इन बैच सिक्वेंशियल आर्किटेक्चर। सो स्टूडेंट्स, दिस इज द ब्रीफ recap about our today's lecture discussion. So till here our data flow centered architecture pattern comes to an end, in which we see sequential batch sequential architectural pattern and pipe and filter architectural pattern. So students, till here our lecture number 21 is ended.